Question number 3. Let's remember to always write out our order of operation so that you have something to follow. I call it a game plan. The first thing we see is parentheses. So I look in the parentheses to see if there's anything I can do. Can I do 7 12s minus 2 12s? Absolutely. They have a common denominator, and so I am actually ready to subtract 7 minus 2 over 12. And this is going to give us 5 over 12. 5 over 12. And then I haven't done the division here, so here comes the division, divided by 1/10. In order to divide fractions, right, so we have parentheses, we had no exponents, and then we're down to multiplication and division. In this case, we are dividing. Here is our division symbol. So let's go into some side math. To divide, we must keep the first fraction, change the sign to multiplication, and then flip the second fraction. So we call this keep, change, and flip. Keep, change, flip. So we have 5 12s times 10 over 1. And you have practiced multiplication before, so we're going to multiply numerator with numerator, denominator with denominator. 5 times 10 is 50, and 12 times 1 is 12. So we have 50 over 12. Notice I have all this side math and I keep coming back to the left to keep updating my answer. What this does is it allows me to keep going with my plan and not get mixed up of what I'm doing. So right now I'm working on this step and I'm thinking, wow, I'm all done because there's only one fraction left and all I have to do is simplify. So 50 divided by 12. Let's check our common numbers, which are the 2, 3, 5. Do they both end in 0 or 5? No. So that eliminates the 5. Are they both even numbers? Yes, they are actually. So I think of 50, it's an even number because I can multiply 2 times something. In this case, it's 2 times 25. And 12 is even because I can do 2 times 6. And so I simplify here, and we are down to 25 over 6. Let's check again. You always want to check again. It doesn't matter what you end up with, check again. How about 2? Are they both even? No, this one's odd, this one's even. So that didn't work out. How about 5? Do they both end in 0 or 5? No. How about 3? Let's check. Actually, this is a neat trick. Check it out. So we're going to have 6. I know 6 is divisible by 3. But what about 25? Maybe I don't know that. So what I'm going to do is I'm going to take the 2 and the 5 and I'm going to add them. 2 plus 5 is 7. Is 7 divisible by 3? No, it is not. Therefore, 25 is not divisible by 3. That's a neat trick. We're going to practice it a lot. And now we know we are done. The answer to number 3 is 25 over 6. Number 4. Ooh, I like this one because they're really big numbers. So I'm going to show you something that shortens our time in reducing. I'm going to show you 2 different methods, okay? So we're going to call this method 1. Method 1, what's going to happen is we're going to multiply, and we're going to end up with really big numbers, and then we're going to simplify. So we're going to go big, and then we're going to simplify. In method 2, we are going to simplify first, and then multiply. Okay, so our numbers will actually stay small. Let's get started with method 1. I always remind you to multiply. All we do is multiply numerator with numerator, denominator with denominator. These are big numbers. In fact, I can't quite do that in my head, so let's take out our calculator. 24 times 23 is equal to 552. And then 450 times 449. So method one, you see how we ended up big, and now we have to simplify. Let's get ready to simplify. And like I've encouraged you, let's use the numbers 2, 3, 5. Is 552 divisible by 2? Is it even? Yes, it is. So I know I can do 2 times. My numbers are quite big, so maybe I can't do that in my head. So what I do is take 552 divided by 2. And the answer is 276. And let's do the same thing for the denominator. Is that an even number? Yes, because it ends in 0. We're going to take 202,050, divide that by 2, and that gives me a nice number of 101,025. We see that I can simplify this 2 and this 2, and we keep going. How about 276? Let's check again. Let's check, is it even? Yes, it is. Is 101,025 even? No, it's not. So I can't use my 2 for now. How about 3? We take each of the digits and we add them up. 2 plus 7 plus 6 gives us 9, plus 6 is 15. Is 15, and this is a question, okay, is 15 divisible by 3? Yes. Now, 5 is not the answer. I know you might be tempted to finish this and say, oh, it's 5. No, it's not. This is just a check. This is just gives me the opportunity to run this number into my calculator. Let's check the other one so I don't waste my time. And you're going to see in a little bit why I didn't finish. 1 plus 0 plus 1 plus 0 plus 2 plus 5 is 9. Is 9 divisible by 3? Yes. Now, neither the 5 nor the 3 are the answer. What am I going to do? I'm going to bring out my calculator and I'm going to punch in 276. Now I'm going to say, hey, it is divisible by 3. Therefore, I can rewrite this as 3 times 92 and 3 times divided by 3. And that gives me 33,675. And we are able to simplify by 3. And I remember I said this is going to be long, so we got to kind of start over. Check for 2. Are both of these numbers, 92 over 33,675, are they both divisible by 2? Are they both even? No. So I'm up here, I'm going through my little list. So here's my 2. I crossed it out, even though it's already crossed out. How about 3? We're going to add up 9 plus 2 is 11. Is 11 divisible by 3? No. How about 5? Do they both end in 0 or 5? No. And one of the last things that I can check is to see if they're divisible by each other. So for example, I could divide by 92 on both the numerator and the denominator. So let's check the denominator to see if it gives me a nice number divisible by 92. You see how I ended up with a decimal? That means that I cannot divide both of these numbers by 92 like this. Therefore, I have exhausted my most common factors, and I believe that I am done. This is method number 1. I like method number 2. Let's take a look at that. All right, so the first thing I'm going to do is I'm going to take each of these numbers and I'm going to simplify them already. So 24 is something I can do in my head. I can do 2 times 12. But 12 can be simplified even further. Let's simplify 12. 12 can be 2 times 6. But 6 can be simplified even further. Let's do 2 times 3. So this is actually called prime factorization. It's very important because it's going to break down my numbers as far as they go, and I don't have to worry about missing anything like I did on top where the numbers were too big. Let's do this for 450. So I'm thinking about 45 times 10. And I know sometimes I ask you to start with 2's. If that's what you can think about, then start with a 2. I noticed the 0, so I know there's a multiplication by 10. My 45 can be simplified to 9 times 5. And my 9 can be simplified to 3 times 3. So I have 3 times 3 times 5. How about my 10? My 10 can be simplified to 2 times 5. And I know you're thinking, this is taking forever, but it's actually easier than this over here because those numbers were so big. 23, how about 23? Can we simplify that? That is a prime number. There's no other number that multiplies to 23 other than 1 times 23. Let's do 449. If you cannot think of a number that multiplies to make 449 because it's such a large number, we can take your calculator, and what we're going to do is we're going to look for a number that divides nicely into this number. Let me help you get started. So you're going to divide by 2. So if you notice, it gives you a decimal, so that's not a good number. So we move on. How about 449 divided by 3? Nope, you see how it's a decimal? Not a good number. 449. I know 5 is not going to work. I'm not even going to try it. How about 6? Well, if 3 didn't work, 6 is not going to work. How about 7? Let's try 7. That didn't work. And so I've tried so many combinations of this that I'm pretty sure that you cannot simplify this. I am going to write 449. So now what I have left is, let's go ahead and simplify anything that we have in common here. I'm going to go from left to right to make sure that I don't cross out too many things or miss anything. So I have 2 divided by 2. That crosses out. How about, do I have another 2 on the denominator? No, but I do have a 3. So let's cross out one of those 3's. So in the numerator, I have 4 times 23. And that gives us 92. And 3 times 5, 3 times 5 is 15 times 5 is 75. And then 75 times 449. And we end up with 33,675. Quite a large number. So although method 2 seemed a little bit longer, it was because I was sitting here and, explaining thoroughly, but method 2 is actually quite shorter.